Cool. All right, it's showtime. Let's see. So we're here in Reaktor. Yeah, make sure the audio is coming through all right. Yeah, so we've been doing a lot of work here. There's a lot of crap I've been making in Reaktor. Let me just save this ensemble real quick. Say this has 5, but yeah, we're working on basically what I don't know what I'm gonna call it, but it's a little system of blocks that work sort of in parallel together. I'll show you what I mean real quick. So if I just let's just make a new rack, frankly. So I'll just show you something cool here. I'm gonna set up something. That's an overdrive thing. Yeah. We'll load up that. We'll load up a filter. And I'll put up a little VCA. So the oscillator has 2 outputs. Cool. A left and a right channel. Or, I mean, they don't have to be left and right, but pretty much using it at like left and right channels. Filter with 2 input channels, a VCA with 2 input channels and 2 outputs, right? So, yeah, let's just patch this up real quick. We can hear what it sounds like. Alright, cool. So this is the idea. You hear how the left and right channels are different from each other? So you get just this wild stereo effect going on. You can, change it. And so that was like the whole idea behind the series of blocks that I'm making is it's just a system that works on like left and right channels. And I've done a bunch of crap with it. I don't know how else to say it. But I've been using like the newer block format, so look, you can hide all the patch cables. So that's pretty neat. And I wanted them to have this cool design, right? So all these designs are just weird, abstract, oscilloscope looking things. Yeah, basically, I wanted it to look cool and sound cool. So, yeah, that's kind of that's the big idea here. I can open up, so I'll open up this little track that I was working on earlier. This is gonna be the next YouTube video, this little patch. The only thing is, I'm working on trying to, mix and master the thing together. It's very unconventional mixing, as you can imagine. But at least trying to bring this thing into reasonable audio levels without just destroying everything is kind of difficult. So, yeah, anyways. So let's just pull this up real quick. Is it working? Heck no, it's not. Word. Oh, yeah, that's because I have this turned on. Alright, so, yeah, this is the patch. I'm going to make a video with this patch. I'll just show you all here as an example of what the system can do. Yeah, so we can close that out and look at all the connections. Yeah, so beautiful stuff. Really just a bunch of just crap going on, frankly. But that's cool. The idea is, so I guess it's a little introduction of what we're working with. But right now, today, I want to make Two more modules. One of them I want to do just like a sample and hold module. Yeah. I want to do a sample and hold module. I've already made one called the Dual Noise Partitioner. It's based on the based on a Buchla thing, Buchla 266. So what I'll do here, we'll just get like a little oscillator, little bento box oscillator. Yeah, we'll send it some gates, you know. Oh, I guess it's only sending pulses. Weird. Yeah. So this is outputting a noise signal, and we'll just get a scope real quick so we can look at what's going on. Well, actually, if we just... Hello? Oh. You're not gonna do it because... Am I crazy? It's not... Oh, it's because I put it into the sidechain input. Hello? Alright, there we go. So cool. So this is... We've already got some sample and hold things going on here. But what I want to do now is basically just make a teeny little module with this. And I've been looking at, I've got the, you know, the manual cooking up here, the documentation. And so the panel width is just 60, or well, it's the number of units times 60 minus 4, right? So theoretically, a 56 pixel wide module is definitely doable. That's kind of what I want to do today. So I've got one set up here. So this little guy over here. Don't know what it's going to look like yet, but that's okay. Maybe I don't want to show the AB buttons. Do want to show the header though. Yeah, the label. Let's see here. Well, I just pretty much want this to be, we'll just call it GN, maybe for gated noise. Let's see here. Okay. Hold on a second. Let's get an input and we'll duplicate this little bit of text. So let's see here, when B, I want this to be on. Don't want you to show the label. Alright, cool. So we'll go ahead and bring this down. Actually, I can just bring this over here. Word. Frankly, hold on a second. Hold on a second. This is insane. I'm just gonna go grab an input from one of these. Copy it from here. Alright, cool. So we have an input, we have an output, and now we just have to do math, basically. Alright, we got a bunch of crap in here. Dang. I don't want this. Here. And go grab... Wait a minute. You know, I guess it really doesn't... Sorry. I haven't actually totally thought of how I'm gonna do this yet. But I'm also pretty sure that... Yeah, I don't think there's anything I'm really gonna need from in here. Clock select, distributions, and nope. I'm gonna need any of these, I don't think so. Yeah, I don't think so, actually. We have the random seed, and that might be it. Huh. Oh, look at that. And they have a gate input right there. Alright, so we're gonna use that instead. Cool. Alright, just getting everything set up here. velocity gate, reset, don't need that. Okay, A, B buttons, this one's not gonna have those, so it's not going to matter. Yeah. Okay, so the idea here is we'll just take some noise, random seed, we'll just route that to a quick bus. That doesn't even need to go in deeper. Get the random seed, going under there, and then we'll get an audio rate output, and let's just push this out right now. See what we get. Alright, cool. And I'm gonna route the pulse in here. Alright, so let's see here. We'll just connect that to this. We'll call it a gate. Awesome. Velocity gate. I don't want that. Anyways, so right now we see the noise is, I'm pretty sure that line means it's peaking. But anyways, we also only want this to have an amplitude of 0.5. So what I'll do is I'll actually just take the absolute value of this. So right now the amplitude is 1. Now we have an amplitude of, what's it called again? 0.5. It's just shifted up by 1. Which is alright. You know, nothing too crazy about that. It is a little strange that it's clipping right now, but I mean, this way the waveform cannot exceed the display frame. When hitting the limit, oh. Okay, so when it just hits the limit, those orange lines will go up. So I guess that means that it's landing on 1 exactly. I can't imagine it would be exceeding that. So anyways, we won't worry about that. We'll just take a latch. That's what we need. We'll just latch this, connect it to our gate, and we'll send it out. Look at that. And now this is going along with the clock events. So let's actually do, yeah, so now our sample and hold, our noise circuit is going along with those. Yeah. If I get this instead of that, we'll make this the clock source now, which it'll just be a little square wave. Just a square wave. Okay. So, hold on a second. Let me compare this. Okay. So we don't want that. We do not want that. Let's see here. Sorry, I should elaborate a little bit. What we don't want. So right now we've got this pulse signal coming out of here. We'll actually run this into here first. So this pulse signal goes between 1 and -1. And our little, what's it called again? Sample and hold circuit is being triggered when it goes positive and negative. Positive, negative. You can see it on the scope. Changing like that. So I might be able to just take a graded, no. Let's see here, router graded, and we'll say that this is the gate. Yeah, and that works. There we go. Cool, now it's only changing whenever this first signal goes high. Yep, so that's pretty neat. Pretty neat stuff. Okay, awesome. So, pretty simple module here. I'm going to move this all the way over to the right. And we'll compact the board. This didn't compact anything. Love it. Alright. Cool. Great, nothing too crazy. Nothing too crazy at all. Alright, but what we want to do now... Yeah, I don't even need a knob, do I? Yeah, I really don't. Yeah. Alright, so let's not worry about that. Or maybe... yeah, no. We're not going to take a knob. Okay. Anyways. So... yeah. Take this now, and... Alright, so now... basically just have to... make sure that this is sort of the right size. Yeah, at least whenever it's closed, we want to make sure that's the right size, and that's pretty close. Not doing too much there. But now, let's just add a quick little visual to it. Yeah, we'll take an XY out, and let's scale this real quick. Oh man, I do want a button that changes it from unipolar to bipolar. Alright, hold on a second. Before we get too crazy, let's add another one of those. And I don't think any of these buttons are gonna... actually, it will be small enough. And what I'll do is take this. Yep, and we have a button already. We're gonna take, and we'll put it in here. Okay, I'm also going to make that XY box layer 0. Is that just on B? Why? Okay, we'll make that layer 0. We'll do that. Don't show the value. Don't show the label. Alright, the width is going to be 56. Yep. Alright, also, I don't want a large button. I want a little button. So we'll go here and take a little button. A small button. I guess is what I meant to say. Alright, so we'll get that instead. Cool. Alright. So let's bring this guy over here. Slowly. Very slowly. Yeah, one of the big things that I'm not a fan of in Reaktor is how unintuitive the user interface is. But it is what it is. It'll be alright. Anyways. Yeah, so we'll do this. Let's make the transparency like that. Yeah. Cool. And in this button, what we want to do, we'll route that. Why do I have that? Oh, I was going to use that before. I remember. Okay, so right now, so if we just, continuously run this noise, or like run it really fast, basically, we'll get it from 0 to 1, but what we want to do is shift it between, so we'll say that this is unipolar or bipolar. What we want to do is shift it actually, so we'll yeah, okay. So I'm just trying to think of how we can do this. What we can do is actually connect that to a constant. And let's say it's 0.5. Then we'll subtract up here. Yeah, so we'll subtract this signal from this. Connect it over here. Cool. Alright. So now, check it out. We have, and if we just run this forever, right? So if we look at the scope, what we see, so when it's off, the range is 0 to 1. When it's on, the range is negative 0.5 to 0.5. So that's cool. Look at that. Pretty neat stuff, right? Alright, so now we'll just add a little, just make it look pretty, and we'll be good to go. Yeah, I think I want to do that. Anyways, and maybe I'll have like an oscillator running on the y-axis. Yeah, running along the y-axis. Oh, hold on a second. I'll actually take. Oh, Hold on a second. I just realized something. Okay, so here's the thing. I kind of want. So when we do the visuals, right? I'm gonna use an XY little panel element. It's an oscilloscope, is what it is. But it has a set range, right? So we just added functionality in order to shift the range of this, but for the panel element, we want it to just be one set defined range, right? So what I can do is actually just take this and I'll just sample it from the same gate, and we'll get, so we'll label this out, and this will just be for the panel element. So this one is just going to go from 0 to 1. That'll be our input. And let's see here. So, yeah, what we'll do then, and actually, I'm going to take these off for now since we're not messing with any audio yet. So we can add an oscillator. Let's add a ramp. Is this what I want? I guess. Cool. So that's 1. I'll have a frequency of, I don't know, 32. Wait, is that in hertz? Yeah, alright, well never mind. Let's see here. What's a good hertz value? I don't know, 440. We'll do that. And then we'll change this panel element to a scope. Or maybe, hold on a second, I've got to adjust this. Yeah, and this should be 252. We'll actually just do 248. Or maybe 245? 246? Let's see here. Alright, cool. So when I take the frame off, That's what we got. And shift it down one, yep. Alright, so actually, that doesn't look very good. Let me set the ranges. Yeah, so this is what I was talking about with the range. So the minimum and maximum, so we'll just do -1 and -1 for the minimum, maximum is 1. These oscillators, we're setting them to have an amplitude of 1. And what I'll actually do, not that, hold on, assign oscillator, what I actually want. And this will actually take the pitch, which is pretty neat. Which means, and since our, okay, so since our input, or our output rather, of this function is 0 to 1, we'll need to multiply it by 120 in order to get an actual like pitch input. Oh. Well, that's a little tragic. You know what? Why are we doing all that over here? What we can actually do, so we'll put this down here. Why don't we just get a sine oscillator from in here? You know what I mean? And I actually made a little module in here that goes from 0 to 1 to hertz, which is pretty cool. And actually, what we'll do, I'm actually going to save this again, 0 to 1 hertz pitch. Yeah, even though, okay. Alright, hold on a second. So what we actually want to do, firstly, we'll do that, yeah. Alright, all that is good. And that can be our input here. Cool, isn't that neat? Look at that, and now we've got some neat little visuals, except this oscillator, I think, goes... No. What? Why are you only taking up half the screen? What is this? Okay, I guess that needs to go from 0 to 1? I don't know. That confuses me. But, whatever. Okay, and right now this visual is kind of freaking out. Not entirely what I had in mind. But let's see here. What I can do, take the frequency, and that's actually what I plan to do with that. And we'll take the frequency here. Yeah, it's a little too chaotic. I wonder if we can, let's multiply this frequency by, I don't know, 2 maybe? Let's see what we get. Multiplying it by 0.3 gives us something crazy. The only thing is, this just doesn't give us, Yeah, I don't know if this is what I had in mind, to be honest. Let's change the amplitude of this. 0.5? No. 1. Maybe if we change... Can you even multiply this? Yeah, okay. Change the amplitude of this, maybe? 0.5. And I guess that's a little neater. I don't know. So it's on a scope right now, and what we can do, we'll change the graph line. I have it set to 0, 128, 196, just because, you know, 128 is 2 to the something power. 196 is 14 squared. So it makes a cool little number. Yeah. Yep. Okay, what I actually want to do, this whole thing, so this is on A right now. We'll just copy A to B. But for these, for B, we'll turn this label on. Why is it so teeny? Oh no. Dang it. Screwed it up, and I don't want to format that crap. So what I'm gonna do is just steal it. I'm gonna steal that formatting from something else. I'll take an in, I'll take an out. I'm gonna copy those, come over here, paste them down. Love it. Alright, we got better formatting now. Isn't that grand? Okay. Cool. So the big idea here anyways is just that I wanted to have just a little module that'll take an input and an output and doesn't need to take up so much space. It just has one function. You know what I mean? It's freaking impossible to see though. Is the only issue. But what are you gonna do, right? Also, we'll take that output. Yeah, this gotta be about center, right? We're gonna actually center it on this panel element. Let's change it to 0.2. So now we can see if we look really freaking closely that yeah, this is about centered. At least on the panel element. Alright, so we'll take that. We'll take the output. Yep. There we go. Cool. Alright. So now what we'll do, we'll just change some of this text. So out 1, this is an out 1, it's the only out. So we'll just change it to out. And of course, it's not going to frickin' move even a little bit. If we center it, great. Is this one centered? Yes. Alright, we'll say that this is a gate. Alright, so we have a gate input. Great. Save the ensemble, and we can look at, yeah. So when I have this out, it'll just show that. Cool. But in the A view, it hides the wires. So that was the idea. I've never actually made like a sort of 1 unit wide little module like this before, because I mean they didn't have any templates for it. So yeah, well, that's alright. Anyways, we have a little sample and hold module. Oh, we gotta relabel this. That's just on and off. So we'll go to the off label. So when it's off, it's 0 to 1. So can you, hello? We'll just say 0, 1. I guess we'll actually just say unipolar, a UNI. That's cool. And when it's on, we have -0.5 to -0.5 to 0.5, so we'll just do bye. Neat. Okay. Cool. Alright, this isn't a sample and hold module, this is just a, I don't know, what the heck should we even call this frickin' thing? Gated random? Does that sound good? You know? I don't know. Alright, we don't want that. We don't want that. Do want the header though. It's pretty convenient. Do want the label. Alright, yeah, so I guess we'll just say that real quick. Once we're done with this, we'll do some patching. We'll screw up some sound. See if we can't make anything terrible. So I'll say this is gated random. This a gate, and it will spit out a random voltage, I guess. I don't actually know what these signals are really called, to be honest. That's okay. Yeah, a random seed should be random. Display clock isn't even frickin' needed. We'll actually take that out because that's not important. Okay, great. So now we can save this. So I'll say that this is a modulator, gated random. Cool. Alright, that's pretty neat. So now, I look at my files here. Alright, actually, let's get rid of this. Let's get rid of the scope. So, theoretically, if I put 3 of these down, it'll at least be close to 6 units. Let's put this here. Yeah, actually, I think that's right on the ball. I think that's pretty freaking neat. And you can look at their oscillations too to make sure that we've got, you know, different random seeds, right? All right, so this was cool. This is cool, but let's get to making some sounds here now. All right, so we made a quick little module. It's got those little corners on the end. I don't know why. I don't know why it has those, but that's okay. So, yeah, so this was also sort of built. A lot of this was inspired by Metaphysical Function, which is a little synthesizer in this program. But anyways. So I've got 2 FM style oscillators here. Actually, you know what? Yeah, we won't even have to worry about that. Let's just build it like this in the bay. So we've got 2 of those. And I've also got, all right, so I'll go into a little bit of explanation of just something that we're cooking up here. So I've got 2 oscillators here. They're basically FM oscillators. And this here, this was actually stolen, not stolen, but like the idea was stolen from Metaphysical Function. It basically it has like 2 sides, you know what I mean? I mean, it'll let you change the amplitude of of the 2 sides, right? So we'll just call them side A and B, right? Or we'll just, yeah, because that's what it is on that synthesizer. So on A and B, you can change the volume of those, and you can also crossfade between, are you summing the signals together or multiplying the signals together? So, well, that's what we're going to do here. So this will crossfade the left and right channels together. That's an input. Alright, and so we can see, well, firstly we get these just crazy psychedelic shapes coming out of that module. It's pretty neat. We can hear what it sounds like. Terrible. It sounds like just horrible frickin' noise. Isn't it great? Isn't it great? Look at that. Look at that. Freaking, what even is that? Alright, so, yeah, we're actually gonna start there. We're gonna make a little noise source. And, yeah, it's gonna sound terrible to start out, and it might even sound terrible at the end, but we'll see. Yeah, there we go. Okay. That's pretty neat, isn't it? Here. Yeah, so what it's doing, we're combining J and Q. Okay, so the left outputs, I mean, they're not, I've got things defined with such crazy frickin' variables. It's actually, I don't know if it's worth it to try and figure this out right now. Never mind. Basically, combining the left channel, the two left channels and the two right channels, I'm either adding them or multiplying them together. And when you multiply them, of course, you get ring modulation, right? That's the idea. So, we don't even have to have FM. We can just... Actually... Alright. Yeah, that's actually a pretty neat little sound there, honestly. I think that's a pretty cool starting point for a sound. So we've got that, and we can, so I've got a little wavetable synth here. And what we can do is scan through it and find a neat little table for modulation. Let's see here. It looks good. Yeah, I don't want anything too crazy here. Maybe... Maybe we should just go with the regular LFO. But this will be fine. So what I can actually do... Okay. Let's see here. We'll route these here. Cool. Alright, so that's pretty neat. We'll take this, we'll get ourselves a pair of sine waves. Or some sine waves, just in general. Actually. Oh, there we go.
Actually, I want a wavetable for that too. Maybe we'll. Here we go. Yeah, alright, so we've got some weird crap going on. Love it. Alright, we'll take this. Route this to A. We'll just start modulating. So the idea here, we're modulating the pitch of the modulation oscillators. And it's just, you know, to give us some movement, right? Cool. Alright, so what we can do, we might just add an AD envelope here. Maybe. Actually, yeah, why not? We're gonna add another one of these classic wave scanners. That's what I've decided to go for with the name here. Make that a square wave, and we'll trigger this little AD envelope with it. That's what this is. Let's see. Cool. Oh, that's because that's controlling the pitch. Jeez. Here. Neat. Yeah, maybe. I don't know if I like that so much. Let's see here. I don't know if I like that so much. Maybe we'll try. Honestly, let's just take another little wavetable here. Yeah, we've got some interesting little waves going on. Let's see. Yeah, here we go. Alright, cool. Look at that. Alright, we'll add some pitch modulation with that too. Let's see here. Maybe I will actually take this. We'll just make that really high. Or you know what? I've actually got this thing. I call this the voltage processor. It actually lets you. It's like one of the Buchla things. Kind of forgot what it was. But it's one that lets you like crossfade between two voltage signals and gives you a voltage offset at the end. A little two stacked thing. Totally forgot what it was called though. Okay, not gonna lie, not a fan of any of that modulation happening right now. Okay, let's just frankly start that over. So we've got this sound. Cool. Okay, did like the idea of having a little. What the heck is this thing called? Yeah. Freaking wavetable oscillator, that's what I'm looking for. Well, honestly, maybe that is enough to just get us started here. We'll add in a little voltage processor. We'll go between a sine and a sawtooth. Nah, not a fan of that. Nope, not a fan of that. Alright, let's see here. We could just run it through a filter. Frankly, maybe that'll give us some inspiration. Oh wait, I did that backwards. Alright. So we'll run this through our filter. We got a low pass here, low pass there. Cool. Alright, and let's get classic. Yep. And what we can do, well, we'll get an AD envelope. We'll just gate that from this. Yeah, cool. Isn't that neat? It sounds... I really think this sounds like very much like a low pass gate, you know what I mean? This filter and this amplifier, like, connected. Cool. Actually, let's take a classic waveform thing, another one. We'll use this one to control the frequency of a bunch of oscillators. So we'll route that in there. I'll route it in here too. Let's see. Maybe I shouldn't change the amplitude of these. Maybe I should just change if we're multiplying or adding them together. Yeah, alright, that's starting to sound interesting. Yes, very cool. Very cool. It sounds nice and plucky. I like it. Alright, let's see here. What we can do... Yeah, why don't we use that new one we just made? Gated random. Cool. So we can use that and we'll actually... use this to modulate the cutoff. Oh, it's like clipping? I guess we shouldn't control the bias with that. The change of the filter is pretty neat. Maybe I can also change the oh wait, I changed the gate? Cool. Maybe I can also change yeah, change how fast the attack and decay is. Cool. Alright. Cool. So what we can do Alright, so I'm gonna take the inverted out from that AD envelope and run it in there. Oh, that's neat. That's pretty neat. Okay, hold on a second. Let's get voltage processor in here. Hold on a second. Yep, so I'll do that, and I'll take another little oscillator out here. Let's see. Yeah. Get another classic waveform. Make it a sine wave. Cool. We're at that to A. Alright, cool. So it's interesting because the range here is going from 0 to 1. Or negative 1 to 1. I mean, this thing only works like that, so we'll need to do this. Which I wonder if I put this all the way down. No.
Alright. Neat. Okay, so that's cool. We can take this now. Here, and let's actually get some reverb in here. Love some reverb. Okay, cool. So oh, that sounds sick. Wait, what is even modulating this? Are these? Oh, but B's not doing anything, so... Maybe... I don't know about that. Maybe. We'll definitely see later. Okay, hold on. So what I've made here as well is a little, it's a filter. It's 6 notches, so it sounds like a little phaser. It's pretty neat. I think it might actually be a phaser, but I'm not totally sure. You just get the weirdest, wackiest crap. You know, let's see. Actually, instead of that, let's take more of our little guys here. This was like, the whole purpose of building these was so I could just put a ton of them in my patches, you know? You always need some freaking randomness in your patches, right? Oh, that's starting to clip. Sorry, y'all. But isn't that neat? No, not good. Ooh, that's pretty neat. That's cool. Oh gosh darn it. Look at that, dude. There's like a pixel of width missing right there. That's a little tragic. But what are you gonna do? Alright, so that's pretty sick. Alright. Cool. Yep. Here we go. That sounds so sick. I know this, you know, random freaking, I don't even know how you describe this, industrial noise, you know, I know that may not be up everybody's alley, but I think it's pretty neat, at least to build, pretty neat. Trying to think of what else we, you know, could even add here. Of course, more modulation, you know. Let's see. Firstly, I'm not using this to modulate. Oh, I was. Maybe I should just add another one of these little random gate things. Actually, I like that. I like the movement that it has whenever it's not just on the beat. So we'll keep that, yeah. This oscillator. Cool. And we can all pack it down like this. Look at that. Okay, that's actually, yeah, I don't know. I think that's pretty neat. I think that's pretty freaking neat, honestly. Let me save this. Okay, cool. I actually think I'm gonna wrap it up there. We've been going for about an hour at this point. I think we made something neat. Some strange industrial noise. Yeah. Cool. So anyways, thank you for tuning in, everybody. Probably gonna do some more Reaktor stuff in the future, just because there's freaking no content for Reaktor out in the world, it feels like, but it's such a cool little environment. Can you call it a programming language? I don't know. Maybe. I think it's a little programming language, but I don't know. Anyways, yeah, thanks for tuning in, everybody. I call it a game. So, take it easy.